All right. Hey, everybody. Happy first video back, I guess. Anyways, we are jumping into Unit 5, which is graphing trig functions, and we are on day number 5, graphing tangent and cotangent. So just a run through of what we're going to do today. So we're going to look at the parent function graphs. We're going to talk about key points and key characteristics of your tangent and your cotangents. We're going to discuss our different transformation rules, and then we're going to do a couple practice problems. So let's get to it. Boom. Okay, so here we go. First off, tangent. All right, we're going to go ahead and we're going to fill in our table for our tangent function using our unit circle values. So just a reminder, tangent is y over x. All right, so at 0 degrees, we know that the coordinates for 0 degrees are 1, 0. So if we're doing y over x, that is 0 over 1, which simplifies to 0. All right, 45 degrees, that is square root of 2 over 2, root 2 over 2. And that is going to simplify to 1, right? So if we're doing y over x, that simplifies to 1. All right, 90 degrees is 0, 1. This is going to give us 1 over 0, which is actually undefined, right? That's going to be important. All right, 135, that's going to give us -1. So that's negative root 2 over 2, positive root 2 over 2. So that gives us -1. 180, that's going to be -1, 0. So that gives us 0. 225 is going to give us +1. So that's our third quadrant angle, 225. So both x and y are negative, so it does simplify to +1. 270, that is 0, -1. So that's going to be 0 over, right? That's going to be -1 over 0, -1 over 0, which simplifies to undefined. Again, that's important. All right, and then 315 is going to give us -1, and 360 is going to give us 0, just like 0 degrees did. Now, let's talk about this undefined. So we've dealt with stuff that was undefined before, and it had us dividing by 0. Those were our rational functions. And anytime we had to divide by 0, that created an asymptote. Well, guess what? In tangent functions, undefined is also going to create an asymptote. So in this problem, we have an asymptote at both 90 and 270. So let's just go ahead and kind of sketch this graph. All right, so right here, I'm going to draw my x-axis. I'm going to go ahead and draw my y-axis. And I'm going to plot my points. So I have 0, and I have 45. Let's see, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we'll just do it like that. Bam, 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 bam. So this is 45 degrees. This is 90. This is 135. This is 180. This is 225. This is 270. This is 315. This is 360. Okay. So just like I said, where we have those undefined points, we are going to have asymptotes. So I'm going to go ahead and sketch those in. So at 90 degrees, I have an asymptote. And at 270 degrees, I have an asymptote. All right, now I'm going to label my min and my max value. So minimum, -1, maximum, +1. So we have 1 and we have -1. All right, and then I'm going to plot my points. Okay, so 0, 0. 45 is +1. 90 is asymptote. 135 is -1. 0, +1. -1, 0. All right, so you have something that looks like this. Now, these are going to be like kind of like cubic functions. So they're not going to be straight lines, so please don't connect these like a straight line. They do kind of curve. So we have this right here, and then we have like this. Now, looking at this, so this is 2 pi. This is normally what we do, right? 0 to 360 or 2 pi, all right? But as you can see, we repeat faster than a period of 2 pi. We repeat every 180 degrees, right? We are repeating right in here. Well, that's 180 degrees, right? That's 90 to 270, so that's 180 degrees, or pi. So unlike sine and cosine, tangent actually has a period of pi, or 180 degrees. So our period is 180 or pi if we're in radians, right? And we have these asymptotes starting at 90 degrees and then every pi. So to find your asymptotes, you start with that 90 degrees because that's our first asymptote that we come to in the positive direction, right? Obviously, you could go backwards at negative 90 if you wanted to, but our first positive asymptote is at 90 degrees, and then it happens every 180 degrees. Right? And we'll times by n, right? N is just our number of rotations, right? So if we wanted to find our, we have 90 and then 180, we can find the next one by, multiplying 180 by 2 and 180 by 3. It doesn't really matter. You don't need to know the formula, but it happens every 180 degrees, right? Every pi. All right, so key things here, all right? We don't really start at 0. Right? Because starting at 0 would give us like half of a full like rotation. So first thing to notice about tangent is that we actually start at 90 degrees and we're going to end at 270, which is 1 full period. All right. So this is kind of a funky one. This is one that it's going to kind of be very obnoxious when we are doing our phase shifting, because instead of starting at 0, we have to pretend like we're starting at 90 and then add in our phase shift. So it's going to make for a really obnoxious problem. All right. So this one starts at 90 degrees, not 0 degrees, right? Normally we start at 0 degrees. This one does not. It starts at 90 because that's where we have our first asymptote. Okay, so that's tangent. Now we're going to do cotangent. And I don't know why I did this, but I'm going to fix it really quick. I wanted to do this one in radians just to give us, 1 degree, 1 radian thing. So I'm going to change it really quick. Okay, so I went ahead and I just wrote in the radian values. All right, we can kind of zoom in a little bit if that helps. Okay, so I took out the degree, I just wrote in the radians. All right, so let's go ahead and fill this in with our cotangent values. So remember, cotangent is x over y. So let's just go ahead and fill this in. So I'm going to go quickly, just kind of write it down because we do have our tangent values right next to us. So hopefully doing cotangent is really easy. So at 0, we actually are going to get undefined. This is going to give us positive 1. This gives us 0. This is negative 1, and this is undefined. This gives us 1, 0, and negative 1, and undefined. Okay. So there is our cotangent table. So now we're going to go ahead and we're going to graph this. All right, so same deal. I'm going to sketch in this, sketch in here. So this is pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. All right, so I just did the whole thing just to look at it, right? This is positive 1, this is negative 1. Okay, so you can see that we do still have those asymptotes, but they are in different places with cotangent. So we have them at 0 and pi and 2 pi, right? But if you look at this, right, this also has that period of 180 degrees or a period of pi, right? This is one period. All right, so we can go right down here and we have this period every pi, or right 180. Okay, but instead of having to start at 90 or pi over 2 for our first asymptote, our first asymptote is at 0, which is actually preferable because it's the same now as sine and cosine, which also start at 0. It's first whole period. All right, so our asymptotes are 0 degrees, or we're in radians, right? So let's just do 0 radians. So 0 pi plus every pi n, right? So any other rotations, right? We just keep adding pi and we're going to find our next asymptote, right? So graphically, right, at 0, we have an asymptote. At pi, we have an asymptote. And at 2 pi, we would have an asymptote. We would also have one at 3 pi and 4 pi, so on and so forth. Okay, so now we're going to go ahead and sketch this. So pi over 4 is 1, 0, negative 1. Same over here, 1, 0, negative 1. So it's like a backwards cubic function. All right, now, you don't need to draw all of this. You just need to be able to draw one period. So this right here is your one period. So all this other stuff, the rest of it I just drew because we already had it in our table, but you don't actually need that, right? You just need between those two asymptotes. So you got to find two asymptotes, and then the graph in between would be your one period. So that is our cotangent graph. So if we kind of compare and contrast, all right, so first off with cotangent, this starts at 0. So this is nice, right? This starts at 0 degrees or 0 pi, right? Same as sine and cosine. All right, so when we do our phase shifting, it's really easy when we're doing cotangent because it starts at 0. So we just do 0 plus whatever our phase shift is. Whereas with tangent, we can't do that. We have to start at 90 plus whatever our phase shift is. So it does get a little bit funky when you're doing tangent. All right, but both tangent and cotangent have a period of pi. Looking at the graphs, if you look at it, tangent kind of increases, right? Increases from left to right, whereas cotangent decreases from left to right, decrease left to right. All right, so they have similar shape, right? They're going to make that S shape kind of thing, but tangent is going to go up as you go from left to right, whereas cotangent goes down from left to right. All right, so kind of remember that, just knowing the shape and things like that. So just pay attention, right? Okay, next we'll look at transformation rules. It is the same for tangent and cotangent as it would be for sine and cosine. There's one difference, and it has to do with the period and the frequency, which hopefully maybe you're thinking, obviously there's going to be a little bit of difference there. But just to kind of jot this down so that we have it, we know that A is our amplitude. That's telling us how far away from the x-axis we go up and down. All right, so that's our amplitude. B is our frequency. C is our phase shift, and D is our vertical shift. It also gives us our midline equation. All right, now, so tangent and cotangent, these letters stay exactly the same. They mean the same thing. All trig functions, they mean the same thing. But for tangent and cotangent, we do have to talk a little bit about the B value, which is our frequency, right? So frequency is like how long it takes us to do one full, or how many rotations we get every period or every pi, where at sine and cosine, it would be how many things we do every 2 pi. Since our period is pi, frequency would be how many rotations we do every pi. So to find your period, it's pi over the b value, or if you're in degrees, 180 over the b value. All right, so that is something that's a little bit different with tangent and cotangent, is how to find your period, because you are dealing with a period of pi instead of 2 pi. Okay, let's jump into our 2 practice problems. So we have the hard one first. So I think tangent is harder because of that starting point. Since we do have that first asymptote at 90 degrees, or this is radians, so at pi over 2, we have to take that into consideration. I'll show you what I mean when we do that. So first off, I'm going to add something here that I should have probably already typed up. We also want to find, where are those asymptotes? Okay, all right, so before we can get started, you need to pull the b value out front. All right, hopefully you did this when you were doing sine and cosine. There's no way to really tell what the b value is or the frequency is without like kind of pulling it out. And you also can't get a correct phase shift without pulling the b value out front. So before I continue, I'm going to change this equation with the b value kind of pulled out from that parenthesis. So we have 3 tangent. My b value is whatever is attached to x. So in this case, it's 1/2. So dividing everything by 1/2, that leaves me with x minus pi over 3. If you don't like doing that by hand, please go ahead and use a calculator. All I did was type in 1/6, right, divided by 1/2, and math, enter, enter, and you get pi over 3, or 1/3, right? Remember to use parentheses, right? Parentheses 1/6 divided by parentheses 1/2, and it will give you your right answer. 1/3. Just double checking, because I didn't use parentheses the first time, and then I was like, whoa, maybe I should have used parentheses. Yeah, so I just double checked and it works. Okay, so pull out the 1/2 and you have x minus pi over 3 left, and then the plus 2, which is our vertical shift on the outside. Okay, so I'm going to go through and I'm going to find all my values. So my a value right here is 3. All right, my b value is this 1/2. My c value is this pi over 3. My d value is this plus 2. All right, so maybe labeling above, right? That's A, that's B, that's C, that's D. Now, some people like to do it like this. So instead of just putting pi over 3 for your C value, you can write in left, right, up, down for like the C and the D. So this one, if it's a minus pi over 3, it's going to be to the right pi over 3. So I can write that. So I can do right pi over 3. And then the plus 2, that is an up 2. So I can also just say up 2. You don't have to. You can just put the pi over 3 and the 2 if you want to. I'm not that picky. As long as it's graphed correctly, that's what matters in the end, right? Okay, so let me move a little closer to the screen. Ow. Okay, this chair is really uncomfortable. Okay, so we have that information. Now we need to find our period, and we need to figure out where our asymptotes are. So to find our period, we're going to take our b value, and we're in radians. So I'm going to do pi divided by my b value, which is 1/2. Right, so this is for the period. All right, and that simplifies to 2 pi. So my period is 2 pi. Now, the next part people tend to get wrong with tangent. Remember, tangent does not start at 0. Tangent's first asymptote is generally at pi over 2 or 90 degrees. So to find the asymptote, you have to start with pi over 2 and then add your phase shift. So it usually is at pi over 2, but we're now shifting it to the right pi over 3. So I start at pi over 2 and then I add pi over 3. And that's where my first asymptote is going to be. All right, so I'm going to again go to my trusty calculator and I'm going to type in 1/2 plus 1/3, math, enter, enter, and that is 5/6. So 5 pi over 6. Okay, hold on. There's an easier way. I forgot. It's been a whole year. All right, so instead of doing that for your asymptote, because then you have to, so changing the period changes where like our starting point is, kind of thing. So instead of trying to have to add the thing and then deal with your period, there's a faster way to do it. I just remembered. So what we're going to do is, instead of trying to kind of think about it in our head and say we're going to start, we normally start at, 90 degree or pi. So we're going to do our shift, but then you have to deal with the frequency. There's a faster way. So basically all we're going to do is we're going to take this whole piece of the equation in here, and we're going to set it equal to where we normally start. That way we don't have to do it in our head, right? So let's just do it algebraically instead of thinking about like how much we're shifting everything by. So we're just going to do it kind of algebraically. I think it's a little bit easier. All right, so we're going to take this whole thing and we're going to set it equal to where we normally would start for a tangent graph, which is at pi over 2. Okay, and then we're just going to solve this equation. So we have 1/2 x minus pi over 3 equals pi over 2. And we're just going to solve for x. So I'm going to multiply both sides by 2. That's going to go away. So that leaves me with x minus pi over 3 equals pi over 2 times 2 is just pi. And then I'm going to add pi over 3 to both sides. So that gives me x equals pi plus pi over 3. And so that's 1 plus 1/3, math, enter, enter, 4 pi over 3. Yes, that is what it should be. So that is our first asymptote. So the first asymptote is 4 pi over 3. Okay, sorry, a little confused. I forgot what I was doing at the beginning. This is much easier. Take the big giant chunk inside, you equal it to pi over 2 because that's where our first asymptote should be for tangent, and then you just solve the equation. Okay, to find our second asymptote, you could take that whole thing and equal it to what our second asymptote usually is for tangent, or you could just add a period, right? So if our first asymptote is 4 pi over 3, we know the next asymptote is 1 period later, so you could just add 2 pi, and that's what I'm going to do. So to find my second asymptote, I'm just going to add my period, which is 2 pi, so plus 2 pi, math, enter, enter, and that is 10 pi over 3. So that is going to be my 2 asymptotes that I need to make my 1 period for my tangent function here. Okay, so now I'm going to go ahead and sketch my graph. All right, so here's my x-axis, or sorry, my y-axis. I told you guys, it's taking this much time off is really, really crazy. And then jumping back into like this stuff. All right. So this is my 0. Now you can scale appropriately. What I'm going to do is not scale appropriately. I'm just going to put my first asymptote right here, 4 pi over 3. And then there's always three points. So I know that this is going to be 1 and then 2 and then 3. And then this is going to be my next asymptote. So I don't know if you guys talked about that when you were doing sine and cosine, but there's like a total of 5 points every period. So like if we scroll up, right to right here, we have 1, 2, 3, 4, 5, right? So we have our 2 asymptotes. So we have asymptote, asymptote, and then 3 points in between. And this is how it's going to work for every single tangent or cotangent, right? You have your asymptote and you have 3 in between. So that's what I'm going to do for my thing. So I just went ahead and I did my first asymptote, so now I can do my second asymptote. It's going to be at 10 pi over 3. And I can go ahead and sketch those bad boys in here. Now you have a couple options for how you label the other points, and yes, you do need to label all of your x-axis points. I don't know if Miss Markert had you guys doing that or not, but I would 100% prefer or need you to label your points. Not prefer, it's necessary. All right, but there's 2 ways to do this. You can either take your period, divide it by 4, because you're going to be moving 4 times starting from your first point, and then you just add that value. So you take 4 pi over 3, divide your period by 4, which is pi over 2, and then add pi over 2 each time till you get the next point. Or you can do like the midpoint rule, because all of these points are evenly spaced. So you can, you know, do like the midpoint rule. So you can take 4 pi over 3 and 10 pi over 3, add them together, divide by 2. That gives you the point in the center, and then do the midpoint again. I like taking the period and dividing it by 4. So that's what I'm going to do. So I'm going to take my period of 2 pi divided by 4. That simplifies to pi over 2. So to go from 4 pi over 3 to the next point, I'm just going to add pi over 2. So add pi over 2. So I take 4/3, I add 1/2. That gives me 11 pi over 6. Hold on, let me make sure. I didn't put parentheses. Let me put my parentheses. Enter, enter. Yes, same thing. Okay, just double checking. It never hurts to double check. So this is going to be 11 pi over 6. I'm going to do it again. So I add another 1/2. 7 pi over 3. Do it again. 17 pi over 6. Now I'm going to do it one more time, and that should give me 10 pi over 3, and it does. So now I know that I've done it correctly, because you should end up landing on that last asymptote. All right. So hold on, I'll just roll that up for you guys so you can see it. So just to recap, I took my period, I divided it by 4, and then I added that number, added to my first asymptote, right? And then I just kept adding. That's how I got all my points. Okay, now the rest of it, so we have our amplitudes. Here's another thing that you can do. Again, if you're labeling this, it's great. If you're not labeling it, then you are going to have to make it look appropriate. But since I know that like the center of my graph has been moved up 2, I'm actually just going to make this 2. So that line right there is my up 2. So it's my midline, right? So I just kind of changed my x-axis to be at where the midline would be. It makes graphing a little bit easier, and it makes it fit on the graph better. So that's what I like to do. That's just personal preference. You could keep this as 0 and then just make sure you can fit everything onto your graph. But I know that my amplitude means I'm going to go up 3 and I'm going to go down 3. So 2 plus 3 is 5. So my highest point is 5. And then my lowest point is going to be 2 minus 3, which is -1. So I'm up 3 from my midline and I'm down 3 from my midline. Now I can go ahead and plot the rest of my points. So this is the tangent function. So I know that it increases from left to right. So I don't care. I don't need to plug this into a calculator or anything, because I know the general pattern for this function. I know that this is going to be down, this is going to be midline, and this is going to be up, and that it's going to look like this. Now, if you do want to maybe check out what it looks like in the calculator, you can. I'm going to pull it up just to kind of show you guys how you can check your work, because you can check your work kind of with your calculator a little bit. It's not the easiest thing to do, but it kind of works. Hold on, it's loading. Okay. Oh no. Well, just kidding. I was going to show you guys, but I have to, my emulator is expired license, so I can't use it anymore. So just kidding. I'm not going to show you, but you can, so I'll just hold it up so you can kind of see a little bit. If you go to second and then table set, right? So this second one, so the blue table set, you can change your table to start where your starting point is. So it says table start. So for this problem, I would put my first table start to be 4 pi over 3. So I would just type in literally on that first row 4, the pi symbol divided by 3. And then the next thing is like a triangle, and then it says TBL equals. That's how much you want your table to go up by. So I would do mine as pi over 2, because I'm starting at that asymptote and then I'm going up by pi over 2. So I would go down to that second one right here that says TBL 1. and our TVL equals, triangle TVL equals, and I would put in second pi divided by 2. And then when you go to your table, you can see if you've done it correctly. You should have an error at that first one. All right, so you can kind of see mine. Hopefully it focuses. So you have an error. That's telling you that you, yes, indeed, you do have an asymptote at 4 pi over 3, which is where you told your table to start. You also have to make sure you go to y equals and put your function in. Sorry, I did that ahead of time. So I put my function into y equals. I changed my table settings, table set, to be my values I wanted it to be. And then I went to second table. And you can see that I have error. And then the next one, I have -1, which is what I have on my graph. And then I have 0, and then I have +1, and then I have error. So that's my next asymptote. This means that I did mine correctly. If you put your thing into y equals and you put all of your stuff, you put in your starting point and you put in how much you're going up by each time, which in my case, like I said, pi over 2, and your first thing doesn't say error, that means you don't have the right value for your first asymptote. So you have to figure out how to fix that. All right, we can go over that during office hours if some of you want to come in and ask questions on how to kind of get your calculator to help you with trig stuff, because it is a little bit funky because you're dealing with decimals and pi values, but there is definitely a way. Okay, quickly, much quicker than I just did that last one because we are at the 30-minute mark for this video. I'm going to do the cotangent one right now a little bit quicker. Okay, so again, first thing, I have to pull my b value out. Now, this one is in degrees, so it's a little bit nicer. All right, ooh, let me scroll. There we go. Okay, so again, I took 30, I divided it by 1/3 because that's what I was pulling out, and I got plus 90. So now I can go ahead and fill in my stuff. So my A is 2, my B is 1/3. C, this is left 90 degrees. The D value is 2. My period is 90 divided by, 180. Whew, man. 180 divided by my B value, which is 1/3. So 180 times 180 divided by 1/3, 540. So my period is 540 degrees. Now for my asymptotes. So we did the funky thing over there for tangent because we didn't start at 0. This function does start at 0. So you can just do the left by 90, but we can do the same technique if you want to. So I'll do it real quick just to show you that it also would work. So remember, we took this piece right here, this whole inside, and we equaled it to where our function would start. So in this case, cotangent starts at 0. It has its first asymptote at 0. So I would say equal to 0, and I want to see where that piece is now moving, right? So I have 1/3 x plus 90 equals 0. So I multiply by 3. So x plus 90 equals 0, because 0 times 3 is 0. And then subtract 90. So x equals negative 90 degrees. All right, or you could have just said left 90. All right, so since we start at 0, there's nothing funky. Your first asymptote is just whatever your phase shift is, which is not the case for tangent. So for tangent, you have to not just do the phase shift, you have to deal with the whole, it starts at pi over 2 or 90 degrees, so you have to deal with that separately. So anyways, tangent or cotangent is easier to graph than tangent in my opinion. All right, so your first asymptote is at negative 90. Negative 90, all right? And then the next asymptote is 1 period, like forward, right? So to find my next asymptote, I'm just gonna add my period, which is 540 degrees. So I have negative 90 plus 540. So my next asymptote is at 450 degrees. All right, so that's how you find your two asymptotes. You just need 2, so that's how you find them. If you want to find more, you just keep adding a period because then you're going to get another asymptote. All right, so now we're going to go ahead and we're going to sketch our graph. Now, because this one does start negative, I'm going to move my my thing right here over. You don't have to though. Seriously, I am not that picky when it comes to graphing. If you just want to do it like this, and just make sure you label, I'm fine with it. I'll show you. I'll do it like this. All right. So again, we're just going to do our 5 points, right? And then I just label it. So my first one is -90. So remember, if your problem is in degrees, I want you to graph it in degrees. If your problem is in radians, I want you to graph your function in radians. All right, so please don't convert something in radians to degrees and then graph it using degrees. That's not what we're doing. Whatever units I give you in the problem, that's how you should graph your problem. Okay, so -90. Now, I know, and my next one is going to be at 450 degrees. To find the pieces in between, same technique that I used for the last one. We're going to take our period, 540. We're going to divide it by 4 because we're moving 4 times, right? Look, 1, 2, 3, 4, right? We're moving 4 times. Okay, and 540 divided by 4 is 135. So I start at my -90 and I'm adding 135 each time to get to my next point. So -90 plus 135 is 45, plus 135 is 180, plus 135 is 315. And just to double check, I do it one more time to make sure I end up at 450, and I do. Check. So I have done my increments correct on my graph. So now I'm going to put in my asymptotes. So I have one at -90. I have one at 450. All right, and then I have to label my y-axis. So I have a midline at 2. So I'm just going to label this as 2 because that's my midline. All right, and then I know I'm going up 2 from the midline. So that's going to be 4 because 2 plus 2 is 4. And then I know I'm going down 2 from the midline. So this is 0. Again, you could do 0 as the bottom and then just scale up. Some people just have a hard time making everything fit on the graph that way. But again, it's personal preference. As long as you label everything, that's what matters to me. All right, so this is how I have mine. All right, so now I'm just going to go in, and I know cotangent starts at 1 and then decreases. So it's going to be up, down, down. There we go. All right, there is my cotangent graph for this function. So I know this was a bit long. Sorry, guys. We had a lot to talk about with graphing. It was my first video back. It was long-winded. I apologize. Hopefully, if you didn't need all the explanation for the practice problems, you just kind of skipped ahead. All right. Anyways, I will see you guys in our next video. Bye.